Hi everyone, let us discuss few difficult as well as moderate question of JEE Main 2026 of for the maths obviously. So here this question came in the JEE Mains 2026. Let us try to solve this question. So they are talking about f of x will be this limit. So what is the value of this one we are going to have now? So do one thing. First, let us try to solve this greatest integer function. So we know that greatest integer function can be written with the help of x equal to greatest integer of x plus partial fraction of x. So using this concept, f of x can be written as limit n tending to infinity 1 by n cube and summation. This greatest integer will be written as what we are going to get now, x minus, so k square upon 3 raised power x minus partial fraction of k square upon 3 raised power x. That's what we are going to have now. So now what I can do it here, limit n tending to infinity, if you separate the summation along with 1 upon n cube, so 1 upon n cube summation k square upon 3 raised power x and then minus 1 upon n cube summation, this will be fractional part of k square and then upon 3 raised power x, correct or not? So if you see very carefully, so range of this number, this is nothing but this is supposed total you are going to get the lambda, right? So we know that lambda will be always in between 0 to 1 itself, correct or not? So sum of all the fractions till up to n will be obviously less than 1. So obviously their limit will be how much you are going to get now. If you take limit, so limit will be nothing but 0 itself, correct? And here k goes to 1 to n, so 3 raised power x I can take outside. So what we are going to get now, limit n tending to infinity 1 by n cube and 1 upon 3 raised power x. Here what left out, 1 upon 3 raised power x we have left out, and then some summation of k square where k goes to 1 to n we are going to have. So f of x, what we can write out, limit n tending to infinity 1 by n cube 1 upon 3 raised power x, and this will be n plus 1 and 2n plus 1 by 6, correct? So only we have to see the highest power coefficient. So here we will get n into n squared into 2n cube. So 2n cube and n cube will be cancelled out. So only 2 will be left out in numerator. So what we are going to get now, we are going to get 2 upon 3 raised power x into 6. So 2 3 ja. So 1 upon 3 raised power will be added here. So this will become x plus 1. So f of x, what we got it here, f of x we got it 1 upon 3 raised power x plus 1. Now question they are asking summation j equals to 1 to infinity f of j. So now I guess it's easy question. Summation f of j where j goes to 1 to infinity is nothing but it will be summation 1 upon 3 raised power j plus 1, correct? So I guess where j goes to 1 to infinity, so 12, and if you expand the limits, what we are going to get now, it will be 1. So 1 by 1 upon 3 square plus 3 cube plus 3 raised power 4, and this will be goes till up to infinity. It's in GP, and if it's in GP, so how we can find the values here? It will be nothing but it will be 12 first term. So 1 by 3 square upon 1 minus r will be what? 1 by 3 itself. So this will be 12 into 1 by 9 upon 2 by 3. So 3 3 ja and 2 6 ja and 3 2 ja. So final answer 2 we are going to have now. It means first option will be the correct one. Alright. Now see the second question. If you see that cos alpha plus beta they have given, and sin alpha minus beta they have given, and this information, so they are asking 10 to alpha will be equals to. First of all, few information we should see that cos alpha plus beta is negative. Can you see that? It's a negative. So if it is negative, then alpha plus beta will be what? Since alpha goes from 0 to pi by 3 and beta goes from 0 to pi by 4, so if you add, so alpha plus beta will be pi by 3 plus pi by, so 4 pi plus 3 pi, 7 pi by 12. So obviously it will be less than 180 degree. So alpha plus beta is negative, so obviously alpha plus beta belongs to second quadrant because it's negative they have given, right? And obviously alpha minus beta, if you see that 0 and then 0, this will be 3 pi, so 4 pi minus 3 pi by 12, so pi by 12 we are going to get now, right? So which belongs to first quadrant itself, correct? Now they have given tan 2 alpha, so we know that 2 alpha can be written as alpha plus alpha. So what I am doing, I am adding beta and I am subtracting beta, because alpha plus beta I need and alpha minus beta I need. So this one as a one angle consider and this one as a one angle consider. Now apply tan both sides, so tan 2 alpha will be equals to tan A plus tan B upon 1 minus tan A into tan B. So we will simplify, we will get the answer. So question is how to find tan alpha plus beta. So obviously we know that cos alpha plus beta, we know how much do we have given, minus 1 by 10. So do not bother about negative sign because already we know it's in the second quadrant. So tan alpha plus beta will be also negative. So tan alpha plus beta will be also going to be negative, but which angle? So if you see that this will be 1, this will be 10, so this will be 100 minus 1, 99, so root 99, so root minus root 99 we are going to get now. And similarly what we can say that, similarly we can say that sin alpha minus beta, sin alpha minus beta will be equals to 3 by 8. So what is the value of tan alpha minus beta we are going to get now? So again it's a first quadrant, so 3 will be here, 8 will be here, so 64 minus 9, 55, so this will be root 55, so this will be root 55. Substitute all the values, so what we are going to get now, tan 2 alpha will be equals to tan alpha plus beta, so minus root 99, and this will be root 55 upon 1, this minus minus will become plus root 99 and root 55. So I will simplify that tan 2 alpha here, okay, 3 we can take common, so can I write minus 11 into 9, so 3 root 11 and 11 into 5, so do one thing, keep it root 55 itself, right, and divide by 1 plus, again here I can write here 3 root 11 and root 55, okay. So what we can write out here, root 55, okay, so I need root 55 itself, all right. So what we can do it here, see that minus 3 root 11 plus root 11 into root 55 I can write out here, and 1 plus 3 root 11, and this will be also root 11 into root 5 I can write out here. So this is what we are going to get now, okay. So this will be, take root 11 common, so this will be how much you are going to get now, so minus 3, so I guess okay, root 55. So if you see that here we are going to have 1 calculation, somewhere we are mistaking, here we can write 3 root 11, perfect, and then this one, so minus 3 plus root 5 we are going to have now, that is not, so root 99 and plus root 55, root 99 plus root 55 upon 1 plus 3, okay. So where we are making the calculation mistake here, root 99 plus root 55, okay. So I guess what we can write out here, if we will take it here, fine, Wait. Okay, sorry. See, what is the mistake we made it here? Here itself, 10 alpha minus beta will be nothing but it will be 3 by root 55. Alright. So, okay, little bit calculation will change it. Alright. Anyhow, concept you got it, so you can do the calculation. So 10 alpha plus beta we got it minus root 99, and this will be 3 upon root 55. Perfect. And then 1 minus plus root 99 into 3 upon root 55. If you simplify, so this will become minus root 99 into root 55 plus 3, and root 55 cancel out, so this will become root 55 plus 3 into root 99 we are going to get now. So here what I can write out, here I can write out minus 3 root, this is 9 into 11, so 11 root 55 plus 3 upon this will be what we are going to get now. I can write out 11, so root 11 into root 5 plus here I can add 3 into 3, so we can write out here 9, and then 3 into 3 9, and root 11 I can take it here. From numerator I can take 3 common, so this will be how much you are going to get now. It will be 1 and minus root 11 root 55, and denominator I can take root 11 common, so what we are going to get now, we will get it here 9 plus root 5. That's what we are going to get now. And if you see the question, so 3 already they have common, so 1 minus r root 55, so r will be how much you are going to get now, root 11, and root 11 if you take common, so s plus root 5, so s will be how much, 9. So they are asking r square plus s, so how much you are going to, r square will be 11 plus 9, that will be 20 will be the right answer. Let's move to the next question. All right, so here can you see that we can find one relation, 1 upon 15C0 15C1 15C1 15C2, and everything is in terms of product we have given. So I am directly writing the general form, product of 1 upon 15CR plus 1 upon 15CR plus 1, correct. Okay, last term if you see that it is going to 13, so obviously r will be here what, r should be 12, so it should start, r should start from 0 to 12, correct. So let us simplify this expression. This will be pi r equals to 0 to 12, this will be 15CR plus 1 plus 15CR divided by 15CR into 15CR plus 1. So I guess you know one result, NCR plus NCR plus 1 will be how much, n plus 1 CR plus 1. So that's what numerator we are going to apply. So numerator I can apply the same result here. So what we are going to get now, tell me. It will be product of r goes 0 to 12, and that will be how much, 15 plus 1 16CR plus 1, and I guess I can simplify it here. So 15 factorial, 15 minus r factorial into r factorial, and same 15 factorial, and then 15 minus r plus 1, so r minus 1 will become, that is 14 minus r factorial into r plus 1 factorial. So again I am going to simplify it here, see very carefully. So can I write out here product of r goes 0 to 12, numerator if you simplify, so 16 factorial upon 16 minus r minus 1, so 15 minus r factorial and then r plus 1 factorial, numerator goes to denominator, so 15 minus r factorial 14 minus r factorial r plus 1 factorial upon 15 factorial whole square. So see that what I can cancel out from numerator and denominator. So 16 factorial numerator is what? First of all 15 minus r factorial will be, this number will be cancelled out with this one, r plus 1 is going to be cancelled out with this one, correct. And 16 factorial converter is 16 into 15 factorial, and numerator what left now, 14 minus r factorial and upon 15 factorial whole square. So here again one power will be cancelled out. So what left out here? We got it. Product of r goes to 0 to 12. This will be 16, and then I can write out here 14 minus r factorial upon, this is 15 factorial. 15 can be done as 15 into 14 factorial, correct? So again 16 by, here product of 16 by 15 I can write out here, and 1 upon, I can write 14 factorial goes 14 minus r factorial and then r factorial. If you see very carefully, this number is nothing but it will be 14cr. So I can write out here product of r goes to 0 to 12, 16 by 15 and 1 upon 14cr. Now you have to see very carefully, we are taking the product. Many students what make mistake, they took common from here and then they are solving this one. No, it's a product, so this will be multiplied as many times as we are taking the products. So we are starting from the 0 and going till up to 12. So 1 to 12 and this one will be 0. So 13 times we are moving. So we can write out 16 by 15 raised to power 13 and then 1 upon 14c0, 14c1, 14c2 and that is 14c12, correct? So in the question can you see that everything they have given till up to here and alpha raised to power 13. So obviously alpha will be nothing but, if you compare, alpha will be 16 by 15. So in the question they are asking 30 alpha will be equals to. So 30 alpha will be nothing but it will be 30 into 16 by 15 2. So this will be 32. 32 will be the correct answer. So second will be the correct one. Okay. Now next question. Okay, this is the also very tough question. Not at much, but yeah, generally this type of questions you might haven't seen during the practice time. Alright, so let us try to solve it this question. First of all, do one thing, directly you assume the question itself. Question what they are asking, this number, so you assume, let us assume Bn will be equals to an minus 2 by n square. That's what we are going to assume. Alright, okay. So what is the value of an we are going to get now? So n will be equals to Bn plus 2 by n square. That's what we are going to have. Now see, actually I need a1, a2, a3, few terms I need it here. So let us calculate further itself. If I take n equals to 1, so this will become a2. a2 equals to 1 by 2 a1 and plus if you substitute here n equals to 1. So this will become 1 square. So 1 minus 1, this will be cancelled out. So minus 2 here and 1 plus 1. So 2 whole square. So 4. So minus 2 by 4 we are going to get now, right? So minus 2 by 4 and a1 already they have given 1. So 1 by 2 minus 1 by 2, that is 0. Now a3 if you calculate, so 1 by 2 a2 and plus n equal to, we are taking 2. So 4, this will be 4 and this will be also 4. So 4 minus 4, it will be cancelled out. So here we left minus 1. Minus 1 left out, divide by, and if you take n equal to 2, so this will become 2 whole square. So 4 and 2 plus 1, 3. 3 whole square, 9. So this will be 4 into 9, 36. So this will become 36 and a2 will be 0. So minus 1 by 36. Similarly, one more a4 also, let us calculate it here. So a4 will be how much? N equal to 3 we are taking. So 1 by 2 a3 plus, if you take 3, so this will become how much? 3 whole square. So 9 and 3 2 just 6 minus 1. So what you are going to get now? Minus, so 9 minus 7. So this is we are getting 2. And if you are taking 3, so 9, 3 plus 1, 4, 4 whole square, 16, 16 we are getting here. So minus 2 by 16, minus 2 by 9 into 16 we are getting here. So 2 8 ja, so minus 2 by 72 we are getting, correct? So I can write it here, minus 2 by 72 and 1 by 2, this will be minus 1 by 36 and minus 2 by 72. So this will be minus 1 by 72, minus 2 by 72. So this will be minus 3 by 72, correct? That's what we are getting here. I guess I can simplify it here also. So minus 1 by 3 2 ja and 1 3 4 ja, minus 1 by 24, and this will continue, correct? So no need to calculate further, you just see till up to here itself. Now if you let us try to solve here again. So Bn, we assume this number, this is the Bn we have, which we have assumed. So what is the value of an we are getting? So Bn plus 2 by n square. Now if you will substitute this value in this question, so an plus 1 will be nothing but Bn plus 1 plus 2 upon n plus 1 whole square, and then it will be equals to 1 by 2 an. An will be how much you are going to know? This number. So an will be Bn plus 2 by n square, and then same values, n square minus 2n minus 1 upon n square n plus 1 whole square. So I want the values, so here I can write Bn plus 1, and this will be plus 2 upon n plus 1 whole square, and this will be equals to 1 by 2 Bn, and 2 to cancel out, so 1 by n square plus n square minus 2n minus 1 upon n square n plus 1 whole square. So what I can do, that I can take this two number one side, and this every number will be in right hand side. So Bn plus 1 minus 1 by 2 Bn equals to this will be 1 by n square minus 2 by n plus 1 whole square, and plus n square minus 2n minus 1 upon n square n plus 1 whole square. So this will be directly will solve this one, because if you see very carefully, n square n plus 1 whole square, if you take the LCM you will get this one itself. So take the LCM and directly add it. So n plus 1 whole square minus 2 n square divided by n square n plus 1 whole square plus n square minus 2n minus 1 upon n square n plus 1 whole square, correct? Now directly LCM I can take it same, and this will be what? N square plus 2n plus 1 minus 2n square plus n square minus 2n minus 1. Anything is cancelling out. So n plus n, 2n square and 2n square cancel out, plus 2n minus 2n cancel out, 1 and minus 1. So this is going to be 0. So we got a good relation. Bn plus 1 will be 1 by 2 Bn, correct? So actually if you see the question, here I have assumed Bn, right or not? This one what I have assumed Bn. So we have to calculate modulus of summation of Bn actually. That's what we have to calculate. So what is the value of Bn from here we are going to get now? So Bn will be equals to 2 times of Bn plus 1. So summation of modulus of Bn will be equals to how much? And obviously n goes from 1 to I guess infinity, correct? Correct. So what we can write out here? We can write out here 1 summation n goes to 1 to infinity. Bn will be how much? 2 times of Bn plus 1. Since 2 is a constant, I can take outside here, and this will be summation Bn plus 1, where n goes to 1 to infinity. So if you take n, the value of n itself, so we will get it here what? We will get it B2 plus B3 plus B4 plus B5 and so on till up to infinity we are going to get now, right? Now question is, what is the value of B1, B2, B3 and so on. So I guess from the first relation itself, Bn we have taken this number, we can find out here. Bn what we have taken? Bn we have taken an minus 2 by n square, correct? So here B1 is not given, directly find B2. So what is the value of B2 we are going to get now? B2 will be how much? A2 minus 2 by 2 square, so 4, correct? And A2 I guess we have calculated initial. What is the value of A2 we are getting? 0. So if A2 will be 0, so this will be 0 minus 1 by 2, so we are getting minus of 1 by 2. Now B3 will be how much? A3 minus 2 by 9. Now A3 how much we got it? See that previously we calculated A3 will be minus 1 by 36. So we got minus 1 by 36 minus 2 by 9, multiply 4 here, multiply 4 here, so that it will become 36. So minus 1 minus 8 minus 9 by 36 or minus 1 by 4 or minus 1 by 2 whole square. Now B4, one more values we will calculate it here. If you calculate B4, so this will be A4 minus 2 by n square, so 2 by 16. So A4 how much we got it here? See that A4 we got it, I guess, minus 1 by 24. So we can calculate minus 1 by 24, minus 1 by 24 and minus 2 by 16 we calculated, correct? So I guess we can take minus 1 by 8 common, so this will become 1 by 3 and plus 2 by here what we are getting here, so 2 by, we got it, 2 by 2 itself, so that is nothing but 1 by 2 and here what we are going to get now 1, so this will be 3 plus 1, 4 by 3, so 4 2 ja 8, so minus 1 by 6, which looks obviously which looks incorrect. Here how much you are getting? 16. I guess somewhere we found the calculation error in the A4 itself. So this will be 72. So minus A4, how much you are going to get? A4 will be if you calculate A4 from here, how much we are getting? Just see once again, we will calculate. So A4 if you calculate, so 1 by 2 A3 and plus 4 means, okay, A4 we are calculating, so here how much you are going to get now? 4, so means n equal to, we are taking 3. So 3 square 9 minus 3 2 just 6 minus 1 upon 3 square 9 and 3 plus 1 4. So 16 we are going to get now. And 1 by 2 minus 1 by 36 and this will be 9 minus 7. So plus 2 by 9 into 16. So we will get minus 1 by 72 and 2 8 ja. So plus 1 by 72. So I guess we are getting 0. And A4 if you are getting 0, so A4 if you are getting 0, so what is the value here we are going to get now? Okay, yes. So A4 here we are getting 0. So let us calculate here again. A4 we are getting 0. So now look at here. We got it what? Minus 2 by 16 and that will be what? Minus 1 by 8, that is nothing but minus 1 by 2 raised to power 3. I guess you got the pattern. See that B2 how much you are getting? Minus 1 by 2 raised to power 1 and B3 will be 1 by 2 raised to power 2. B4 will be minus 1 by 2 raised to power 3. So similarly, will you tell me what is the Bn we are going to get now? So minus 1 by 2 raised to power n minus 1 we are going to get now. Now let us solve the question. So this will be how much you are going to get now? 2, and I can write out here itself. What I can write out, tell me? I can B2 will be how much? Minus 1 by 2 raised to power this one, okay. So minus 1 by 2 raised to power 1, so minus 1 by 2 raised to power, minus 1 by 2 raised to power 2 and minus 1 by 2 raised to power 3 minus 1 by 2 raised to power 4, and this will be continuing, correct? So we can take minus, since in the modulus everything will become plus. So 1 by 2 plus 1 by 2 whole square plus 1 by 2 whole cube, and this will continue, correct? So it's in GP. So what is the answer we are going to get now? So answer we can write out here itself. This will be 2 and first term 1 by 2, 1 minus 1 by 2. So this is cancel out. So total 2 will be the answer we are going to have now, correct? So D option will be the correct one. Alright. Now see the next question. Okay, so we got it, this values. Now see very carefully. A is any set we have given and B is a subset of A such that n of B, okay. So size of B will be always greater than or equal to 2 and the product of all the elements in B is even, alright. So number of such possible sets B they are asking, alright. So see that first of all how many total number of subsets B will be how much? You are going to 2 raised to power 11, alright. Now this contains what? See that this contains, see that this contains subset of size 1, also it contains null set, right or not? and also it contains whose product of elements is odd or even. Correct or not? This is what it is going to be. So first of all, what we have to add it and what we have to subtract it, we have to see very carefully. I am going to count all those subset which has only two elements or which has only one elements and the null, and I am going to subtract from the total number of subsets of B. So what I can write out here, total subsets of size less than or equal to 1. So how much you can write out here, tell me? I guess singleton, if you write out here, so it will be 1. So singleton 1, singleton 2, singleton 3 until up to singleton 11. So total 11 we are going to get and one null set. So plus 1. This is null set and this will be singleton set. Correct? So now total subsets B of size greater than or equal to 2. Correct or not? So how much you are going to know is 2 raised to power 11 and minus 12 we have to do it. Till here it's fine. Now we have to subtract those elements whose product will be odd. So what we can write out here, total subsets whose product of all elements is odd. So obviously we know that if we have to take the product of all the elements which is odd, so every number should be odd, because if any one number will become even, so 100% total product is going to be even. So it will be obviously going to form with 1, 3, 5, 7 and 9 and 11. That's what we are going to get now. So total numbers, how much you have given? 6. So how many subsets I can form here? So total subsets I can form from here will be 2 raised to power 6. But we need total subsets whose product is odd of size greater than or equal to 2. So which one we have to subtract? First of all, singleton 1, singleton 3, singleton 5, singleton 7, singleton 9 and singleton 11. Total 6 and one null set, total 7. So 2 raised to power 6 and minus 7 we have to do it. Correct or not? So 2 raised to power 6 will be how much you are going to take now? 64 and minus 7. So total 57 here we have. So total how much required we have given? This one and minus 57. So total subsets required of size greater than equal to 2 is 2 raised to power 11 minus 12 and minus 57. So let us calculate and see what we are going to have now. So if we calculate what we are going to have now, 2 raised to power 10 will be how much? 2 raised to power 10 will be 1024. So 2 raised to power 11 will be 2048. So 2048 and minus 9 6. If we subtract, so 18 9 and this will be 3, so 7 and 19. So 1979 is the right answer which we are getting. Alright. So these are the few questions which were asked in JEE Mains 2026 and which was difficult, as well as some questions are moderate also. So again,